Hello, everyone. Next session will be a topic around KMP test. It's our honor to have Matthias today. So he's also the Berlin user group organizer, GDG organizer, and also the Rust organizer. So it's all kind of community in Berlin. So let's welcome Matthias.
谢谢. So let's start. And honestly, I have no idea how you don't sweat all the time. Like I just walked here from the subway and look at me. Like it's incredible. I could just take another shower. So let's talk a little bit about KMP. Maybe small words to myself up front. I'm working at a heat pump company, something which is in Taiwan, I guess, completely useless. And we provide a multi-platform app for our craftspeople so that they can install heat pumps more effectively. So KMP is more or less my daily work. So I do Rust in my free time. I'm playing a lot around Android right now and capabilities in there. And as already mentioned, I organize awful lot of stuff. So maybe I'm bored, maybe I have too much free time, I don't know. And last of all, I'm a coin champion. Everybody knows what coin is. Yes, no, maybe? Yes, that's good. So what is a coin champion? Nobody knows. So maybe the people from Coin. I even got a small certificate. That's nice. So, and if you want to connect with me, you can use this little small QR code. You find there my LinkedIn profile. If you have questions or if you want just to chit-chat about the latest KMP stuff, add me there. I will answer, I promise, even though we have 6 times time differential, so normally. So, okay, everybody has, I think. And let's speak a little bit about expectation. What I will present you today is an awful lot of tooling. So because even though we have just 30 minutes, I will overgo the time, I'm pretty sure about that, because there is a lot of libraries meanwhile around the KMP community, and be happy about it. 5 years ago, when I started, there was basically nothing. So then I will give you a couple of advice or tips around KMP, so that it's maybe a little bit more easy for you to do some stuff, and I will show you some code, of course. So. And how we will do that, first of all, I will speak a little bit about basics around tests and so on, why we are doing that and stuff like that. Second of all, tooling, as I said. Then I will present you a lot of libraries. And last of all, I will say something in general about testing on KMP and maybe also about Kotlin Multiplatform in general. So why we are doing tests? Anybody? Is there a good reason to waste our time on writing a lot of tests?
To protect our project.
From whom? From yourself?
From the next chip.
From whom?
If we want to change the code.
Okay.
Before we change the code, if we have I can be more confident to do that.
Confidence, that's a good word. Anybody else?
For DevOps, because we need to deploy new version very fast. So we want to change our code and we know this code no influence of other code we have completely wrong. And then we can use CI and CD quick deploy to the next version.
So you mean it's more about feedback, right? Yeah, that's also a very valid point. Anybody else? So let's maybe start from a different perspective. So we need to prove something, right? That's the first thing. And what we need to prove, first of all, that we bring some value to an end user. The end user could be yourself. But I think that's the most important point about software development. We want to ship something which brings value to somebody, right? And if we don't do that, we already failed. So the second thing is we have most likely stakeholders, even if the stakeholder is still yourself. So we also have to satisfy their needs. So, and if you, for example, work for a bank, of course they want to make money out of, or have a good user experience that they make more money. So, and you have to satisfy the stakeholders as well, because otherwise you get fired. And yeah, that's the sad truth, right? And last of all, we want to prove that we build a product which actually works as we think it does. And that's the hard point, because sometimes we think, oh, it works that way, and what we think is absolutely wrong, right? And or it just works by accident, and actually testing will help us to discover that. And if we look more from our perspective or business perspective, first of all, we want to have something like a risk mitigation. That means simply that we want to find errors and failures or bugs very early, because then we don't have to deal with them later, and we don't risk maybe money from other people, especially when you work at banks and so on. So that's a very important point, I think. That we already said, confidence. We want to actually be confident in what we are doing, and I see that very often, that many developers or engineers are not confident what they are doing, and then start to debug really with printf step by step. So we all been there, I guess. And last of all, cost saving, right? If we find things early in the development, and not like when we already shipped it, it's much easier and less costly to fix those bugs, right? If we already have the product out, then to convince customer to make an update can be very, very stressful. If you work for something like also here in the banking area, or maybe in the food delivery area, where customers are like very hesitant and reluctant to update their devices, and you have to maintain versions which are maybe 3 to 6 years old with all the juicy bugs in it, you don't want that, right? And how we get there, you all seen this, I guess, at some point in your life, the almost famous testing pyramid. We most likely do in our day-to-day job writing an awful lot of unit tests, and that's good because unit tests is our bread and butter. In rare occasions, we write integration tests. So, for instance, if you have to deal something with encryption, you will heavily rely on integration tests, and also you will write some end-to-end tests. But as the pyramid grows on the top, you write less tests, or if you are fortunate and you have something like quality assurance, somebody else writes the test for you, right? And in the end of the day, you don't want to have so many end-to-end tests because they are super slow. I will show you later a small tool with, when we have time. Those tests in real production run for an hour. So just to check if the user story of an app works. So. But it's normal. That's how the game works. And unit tests, you can have a couple of thousands, and they run or should run under 5 minutes or something. So they are pretty fast. So what's the challenge on KMP? First of all, we have some shared code, right? Where we think the code we are writing there does for a couple of platforms the same thing, right? We write something which should work for Android, for iOS, and maybe for web and whatever. Should be the same. Then we have platform-specific code, like we have something on iOS which needs to be like camera bindings, right? They need to be bind to the platform, and we have the same thing for Android and maybe also for web. And then we have the weird stuff. We have platform code which actually depends. We have common code or shared code which actually depends on platform code. That's the third thing, and that's the hard part. The first two parts are relatively easy to address. So how we do that? Common, so or shared code. You have in Compose in multi-platform. You have, if you have shared code. Oh yeah, now it works. This little common folder, right? And you have a common main, and you have a common test. And just put everything which is shared between the platforms in common test, and you will be fine. For platform code, it's the same deal, and you see that can get monstrous, can become a monstrosity, right? You have an awful lot of source sets, and you have for them also test folders. To keep on that in mind on what is there is a little bit hard, but it's possible. So it's manageable. You just put the platform-specific things under the platform. And who did ever work with JS? Nobody. That's unfortunate. because JS has a small quirk. Do you know that currently the JS implementation actually serves two platforms in Kotlin? We have the browser and we have Node.js. So, and you have to address both platforms in one source set. Good luck with that. It's fun. So, and how we can actually deal then with shared platform-specific code. We can use a smart little trick. We can use expect actual. First of all, if we, for instance, just want to say we want to run something just on Android for one test case, and other test cases are common the same, we can define some annotations and say, oh, we have this Android-only annotation, which then works differently also for JVM or JS and native. And for Android, we make, for instance, this. Right, we have an actual source set, and we just disable everything else on the Android only, which looks like this. Right, we have our JVM only does nothing, JS only does nothing, native only does nothing, only Android only does something. For us under test, that's an end effect. That's a no-op annotation. It does actually really nothing. But since this is no-op and you disable everything else, it actually prevents the others from running your tests, but the Android test runs because it's a no-op. So that's a little bit iffy, but if you do that, you have a lot of fun, because out of a sudden you can run a platform-specific tests in common if you need it, and you need it. The same goes for JS. I have a couple of JS examples because JS is the most weird part in Kotlin, honestly. So, and you do basically the same, right? But here it's not a JUnit annotation. It's here the Kotlin test annotation with ignore. You do basically the same. You ignore everything else and just enable then JS by having a no-op operation. That's it. So easy peasy lemon squeezy. So, and the good thing is, via this expect actual thing, annotation stuff, you can actually also put into your source sets or into your test sets roboelectric. And you will need roboelectric at some point when you, for example, do something with base 64 in Kotlin. You most likely want to rely on the platform sources because they already have implemented that. So, and for Android, if you want to test it, you need roboelectric. So you have a lot of fun making this expect actual stuff. So, okay, we can do a little bit more after I take a sip of water. Because with this temperature and speaking, it's really, you know, how we can improve our developer experience, right? First of all, a very easy stuff we can do. We can actually have very descriptive test names, and people, unfortunately, don't make use of it. And what I mean by that is we simply can use backticks, and we can actually write with white spaces wonderful sentences as our test descriptions, right? And the only thing we have to really take care of that we use backticks, right? So powerful, this small character, isn't it great? So, yeah, and having a sentence in your test set or in your test specification and is very helpful, because then you come back maybe after 2 weeks, you read your tests and you actually understand what you mean, instead of having loading failure or something, or loading wrong, because you don't know what the condition is when it's wrong, or what's triggered and so on. You can write all this down in this little sentence. There is one restriction though. It doesn't, you can't exceed 155 characters for some reason. And if you do that, you get very weird errors. So if you get weird errors with having descriptive test names in plain Kotlin tests, you have too many characters. You can have, you can also use something like cotest, which also supports that. But cotest, I don't like so much the test structure, how cotest is doing that. It's a matter of taste, but if you want to use it, go for it. What else can we do? We can use actually custom annotations, which is just a wrapper around power assert. Who used actually already power assert? Nobody? You should use it. It's really, really nice. It's still experimental though, so not everything works, but try it out. And you find something similar also in code-test with code-test assertions. So what I mean with assertions is what we can do is creating an infix function, which has this magical infix operator, and then do something with this, which looks like this in the end. We have a wonderful sentence in the end, right? We can say that a database is not null. That's so much more readable, right? And your brain will actually be very happy about it if you have a lot of tests like this. And you can just read what's happening there. You can also say database must be null or something else, whatever you want, unless you override a keyword that you can't do, unfortunately, yet. Maybe in the future. So, but that is really neat. Make use of it. Is there more? Yes, we have, of course, co-concurrency, and we have flows and coroutines. We love coroutines and flows, but testing them is a little bit iffy, I guess. And there's two nice tools for that. First of all, you have Kotlin X coroutine test. That's very important because this gives you the power of the scheduler. So you can actually simulate time travels, which is very neat and very important. And the second thing is Turbine, which you need for flows, because Turbine can actually subscribe on flows. And that looks like it. That's a little bit longer test set. I walk you through in a moment. First of all, we have this little neat thing that comes from Kotlin test, and that just says, oh yeah, we have here something which runs asynchronous. So, and when we need something asynchronous, we either have a suspending function or we need something like run blocking. And run blocking is not so cool to use since you don't have access to the scheduler. If you use run test, you can manipulate the scheduler and make some sort of time travels. So the next part is just we define an outcome, which is in this case just an error. And then what we are doing, we have our actual subject under test, which is just a view model. I call it here store because I'm with KMP, or how I do KMP, I'm coming a little bit from a different mindset. So for me, it's more like a store because I also use some different design patterns. And what we can do is actually subscribe on some data there, and weather data is nothing else than a state flow. And Turbine gives us the power with just this test extension function to subscribe on it. And in the next line, whether this is just that we reassign the scope we get from the test function because we need it later, since we subscribe on something else. So otherwise we would lose the context or have to do something with the @ sign and so on, and that's not so good readable. So we subscribe on another state, which is an error. We call an action, and there you see a time travel with advanced at idle, until idle. That will just jump to the end of the execution of the coroutines, or of the coroutine scope, which is currently called. And then we can actually check what's happening with a wait item, and that's coming from Turbine again from the context we assigned earlier to weather. And then we can make an assertion on it because we get some stuff out of our subscribed flow. So very neat, cool tool, use it, both. So what's about resources? Resources is a little bit like a very pity topic because currently there is, or JetBrains slowly gives support, but there hadn't been any support for dealing with resources for 5 years now or even longer. And either you use something like Moco resources, which broke very constantly with each update actually, or you had some other things, but fortunately for testing libraries, a nice little person from, I think he's from Portugal, wrote this, Kotlin X resources. I honestly made my own testing resources library, but this is good to use. So, and this solves first of all the problem that you have a specific way to interact with resources under Android or under JVM. That's the most thing you might know how that works. It solves the problem for Apple, right? Because Apple, of course, has their own way to access resources. And of course, we have other native operating systems like Linux. They also have their own way to access resources, and we have even worse JS in the mix maybe. And this JS has two ways to access resources. Hooray. And Kotlin X resources will deal for that for you. You can just use it and have fun. Very neat if you want, for example, to store some JSON files and then use them with Kotlin serialization together for some tests. So have fun with that. The next thing are fixtures, text fixtures. Who actually uses text fixtures in their daily work? Nobody. That's pretty neat to have them because they can just generate auto-generate some values. If you are too tired to always say, oh, here I have an int value, please be 42 or 55 or whatever. And text fixtures are also very important when it comes to property testing, right? And also here you either use arbitrary from Cotest, or I also published a fixture library, which is kfixture, which is based on the JVM version, which is just called fixture, I guess. And that looks like it, and how to use it. And the entire secret around how to create such a fixture library is nothing else than using random. Because with random, you can actually create something like numbers or bytes. And when you have bytes, you can actually then create strings, and anything else goes. Right? You just need to write some generators. And what will does that for you, as I already said, it just creates then some values. Like, yes. This is just the container for the fixtures, and fixture is just an extension function which can generate almost for every value some values. So, great. Mocks. Who uses mocks in their daily work? So I think that's the most controversial topic, I guess. So first of all, currently you have 5 choices which you can use for Kotlin Multiplatform. You can use mock active. This library is really opinionated how to use it. That doesn't mean it's necessarily bad, but if you don't like it, you don't have to use it. But the author of this library really invested a lot of time and love into it, and you see that. The second thing is mockmp. That's done by the people from Codeine, which was an alternative, or is still an alternative dependency injection framework. I honestly don't like so much mockmp because it's not well tested. So there's a big likelihood that you run into some sort of issues, and also the feature set it supports is not that great, and you have to wire awful lot of yourself that it works. Then Mockingbird is the third candidate. Well, that's the oldest one, and you feel it. So I wouldn't use it, honestly. And kmock is my library, but it's not up to date because I'm currently working on the next major release. That takes a little bit of time since I also have to migrate to Kotlin 2.0 and other stuff. And I have a totally different approach. I was more inspired from Python, to be honest, than from something like mock, because mock is, from my terms, too verbose. So you can make it shorter, and you can make use of auto-completion. So that's the fourth one, and then you have mockery, and mockery should be actually written with 2K, not with CK. Mockery is currently the most powerful library in this ensemble, and it's built on top of a compiler plugin, so it's quite stable. I think it's written by a Polish person, and he also invested an awful lot of time in it, and it's actually surprisingly, and I must say I really envy him. He really put a lot of time in it. It's actually quite good, right? And for me, it's a little bit hard to say because kmock was for over 2 years the thing with the most features, and now I have the other library, and now I need to do much more stuff that I get on the first place again. So, yeah. But what you have to keep in mind, mocking in KMP has a couple of constraints, right? So, for instance, if you think it works like JVM, I need to disappoint you, it doesn't at all, because you have to take into account, you also have to serve native sources, and you can't just manipulate binaries of native sources. You can do that if you are very, very good and have a lot of time, but We don't have that, so most likely most mocking library will only work with interfaces and nothing else. So that also gives you a very opinionated approach how to make architecture then already, which is not bad, which is actually quite good, but you need to keep that in mind. Also, something like extension functions is not mockable at all, except you make really bad ninja moves with plugins in compiler plugins, but you don't want that because then you manipulate also the production code a little bit too far, and thus is not so good. So what else? I already said that with Mockery, it's the powerfulest for now. And what is also a very good alternative is always like you can write fakes from hand. That's what actually most people do nowadays because fakes for them are more reliable and more easy to use. And you don't have to rely on external dependencies. So the last thing I actually do right now also again, because sometimes you want to have a little bit more complex behavior in your mocks, and once you have complex behaviors in your mocks, they get ugly. So writing fakes is then a more better alternative, honestly. So let's come to Ktor. So who uses Ktor? At least 3 people. Hooray! So let's quickly discuss maybe what makes Ktor inconvenient. First of all, when it comes to the implementation of Ktor, you have to couple it to a certain degree, and that's not so nice. I don't like it, and I think a lot of other people also don't like it. The second thing is like how to use Ktor is very opinionated because they have an awful lot of extension functions, and we already know we can't mock them, so we have to also rely on that, and that's also not so cool and makes it hard to test, and there's also a lot of boilerplate you have to write and more, right? That makes it really inconvenient, but how we, for instance, can address the coupling, that's actually quite easy. First of all, you should ask yourself what you actually want to know from the test, right? What you assume and so on. That's one of the requirements. The second of all, you can wrap Ktor in a humble object. So that's most likely what you want to do either ways. My normal approach is like I have actually written a builder function around of Ktor just to use it. And the last thing which you can then use is like handwritten plugins. For example, if you want to use serialization, you otherwise have to go always through the serialization to test some stuff. But you can mitigate it just by writing a Ktor plugin to just actually get out of directly objects. That's something you can do. And alternatively, there's also a library called Ktor Fit. You might have heard of it, maybe not. If you don't want to deal with Ktor directly, you can use Ktor Fit, which works similar to retrofit, actually. So you also write their interface, and that will generate the client for you. So, and that also have some impacts on the tests, of course. So how we can address Ktor's opinion. Also here, we can write a humble object around it and just wrap it. Easy peasy. And last of all, to address boilerplate and stuff in the tests, what you write is test factories, like create a mock client, and those test factories then just pull out the mock client you want to have. So easy peasy. So who uses databases in their KMP project? Who uses SQLite? Nobody. That's the go-to tool when it comes to databases in KMP, and you should also consider it for your Android projects. If you are thinking Room is cool, this is much cooler, because SQLite has one killer feature which Room doesn't have. You can actually bind your tables to a feature, and you don't have to rely on a big Room module where all the database tables for your application are living. You can spread your tables over the entire application with SQLite, and that makes stuff so much easier, so much prettier. I really recommend SQLite to use. So, and for KMP, that's the only stable library which actually works anyway. So Room is still in alpha, so you will run into a couple of issues. And Room currently, I think, also doesn't support every platform. It's only iOS and Android, if I remember correctly. So SQLite actually supports everything, so you want to use it. So, and did I forgot something? So the problems here you run into that is a little bit like also like with Ktor, you have to deal a little bit with setup for the platforms, and you need a little bit like a strategy to test it. And that's easy to address because the only thing you have to do, you should test your SQL schema independently from your integration, because that makes it much easier to detect errors in your SQL definition already. You should test your migrations. You should also do that on actually on Room, even though many people claim you don't need to do that, but in some cases you need to do that, right? And last of all, you also should test your interactions with the database. That's a little bit different than your schema, because you can have something like a wrapper around also your database interactions, and that can be separately tested, and that makes your life much, much easier to find bugs, honestly. So. And there are also some small pitfalls with SQLite. First of all, if you use it, you should make sure that you add the dependency directly in the class path. That just means if you use something like build source or convention plugins, add it there as a dependency, nothing else. So, because otherwise you might run into weird bugs when it comes to spreading your tables over features. You need to know that to find this issue is actually quite hard otherwise. So if you use web, you need a little bit extra setup for Karma and Webpack. That's a little bit hidden on the SQLite tutorial page, but you need to know that you can look for it, and then you will find it. Then you should use await something instead of execute. So, and also a big learning was for me, like, don't expect SQLite to behave the same on every platform. They are working similarly, like foreign keys, for instance, doesn't work for iOS at all, but it works for Android. And for web, it works again, so that's a little bit of weird. And if you want to write integration tests with SQLite, use the in-memory database. Don't try to do something like container testing, because otherwise you waste an awful lot of your time. So, Coin. Who uses Coin? Hooray, at least 3. So, Coin you want to use in your KMP project, because once you have dependency injection in place, it makes decoupling stuff much more easier, and it also means testing get much easier. You can apply totally different patterns, so Coin is your friend. And the backflip of that is also you need to test your Coin definitions. If you think now, oh yeah, in HILT I don't have to do that, that's actually not entirely true, because once you use interfaces also in HILT, you have to test your HILT definitions. Otherwise, you can't be sure that it really, really works. Am I over time already? Oh yeah, sorry. So, and yeah, Coin is really handy when it comes with compose. Let me quickly skip over this. That's just a Coin test. You just need to know you need to use Coin application, then define a module, and actually put your resolve your definition of your Coin module where you're working in, and add some dependencies you need, and then you can simply just pull them out and check if that is working. That's all you have to do. So, and that can really run also as an integration test, and that's it. So what's with UI tests? This is a really cool tool, Roborazzi. I highly can recommend that. It's made by a Japanese person, so check it out. So what's with integration tests? I can just say use them in a separate module. I think JetBrains will add in the future some support for them in the actual source sets to have them separated from the unit tests, but for the time being, just put them out. Don't put them aside your production code, because that gets very quickly very confusing. So, and also Coin here is a great help, so utilize it, and try only to write integration tests for really complex stuff. Don't do it for simple tasks, because it can be very cumbersome then when you lose isolation to find bugs and so on. So what is with end-to-end tests? Who uses Appium? Appium is built on top of Selenium or Selenite. I'm not sure because they change it from time to time. That's quite handy if you have to do some really fine-grained stuff and you want to program your tests. That's the go-to tool, but for convenience sake, Maestro is the much better tool, honestly. And this one I really can recommend because I'm now in the second team where I introduced Maestro to our quality insurance, and they picked it up very quickly. So in 1 month, and you can test on Maestro for iOS and for Android, and they're currently working on the web support. And everything is defined in YAML in the end of the day, so it's easy to use, more or less a low-code solution. And what else is to say about that? You also can use it with your device, at least for Android, so check it out. Some general observations in the end. So first of all, you want, if you want isolation, you need interfaces, also a lot of them, but interfaces are very cheap, so you should utilize them. I honestly do that meanwhile also on Android, because if everything has an interface except for functions which are deterministic, there you might not need it, you get much more flexibility. So the second observation is if you have a good architecture for your application, you will see your tests are really easy and you don't struggle at all with testing. So, and the last advice is don't assume everything works the same on each platform. A good example for that is like the Kotlin XDatetime library. You will figure out very quickly that the outputs for JS, for Android, for iOS, and for native are completely different. If you don't know that and your tests are failing, you will think at the beginning, like, why? And look for days for a solution, and the solution is like, oh yeah, it doesn't work the same on everything. So, okay, then let me come to an end. If you want to get feedback, I have a really elaborated Google Docs formula, so where you can fill it out and tell me what I did wrong, what I can make better next time, so that I also can grow. 1, 2, 3. So everybody done? Not yet. You can't?
Because the character doesn't have it.
Wait, I can help you with that.
The boundary is
Yeah. I can. Where's my mouse? I actually tested that and it worked. You know how it is. So, damn it. Let me quickly make this. Make this. iPhone did? Yeah, I tested it on Android, and honestly, so even more surprising. So format, get I know a border. Yes. So try again. With the border it works, right? Ooh. So, and then if we have 5 minutes for questions, now's the time. Sorry that I was a little bit too long, but who wants some sweets?
We also have some alcohol from Berlin at our booth. So if you want to try, Matthias has sponsored our alcohol drinks. Yeah, so.
So, do you have questions? Yes, no, maybe?
大家有没有什么问题想要问 Matthias？
So, otherwise, we are done.
Yeah, Matthias, how about sharing your magazine?
Ah, the magazine, right.
Yeah.
I will give you later, or
Yeah.
I can show you that. I have, of course, I just wanted to show that to other people. Who has none of them? I have 2 left.
It's a limited edition right now.
No, it is actually a limited edition because we don't print them a second time.
Yeah.
Third time. So I have 2 left, so somebody can grab that. I will just leave later a QR code on the booth where to find it online. But this is the printed version, which was sponsored by Kotlin Weekly, actually. And I think Snap Automotive actually gave the money. And then Kotlin Weekly has promised us to finance the next edition of that thing. Because we prepare a second magazine right now. So if you want one, I have 2 left. So, yes.
Yeah, go for it, go for it.
Yeah?
Yeah, go for it. Actually, we have the PDF version online. So if you didn't get a physical one, you can get it online.
So when you have no questions, then we're done and stop here. And you can have a great day today.
Yeah. Okay, thank you.